Welcome, ladies and gentlemen. So what I'd like to do is show you how to evaluate for the double angle of sine, cosine, and tangent when given an equation, cotangent theta equals 3, and given a constraint of theta equals, or theta is in the first quadrant. So the first thing we need to do is identify what our right triangle is. Because the first video I showed for this, we were given a right triangle. And that was kind of simple enough. You're like, all right, great, we have a right triangle. Now what do we do, right? So well, we have a right triangle, then we just use the formulas and plug in the values for sine, cosine. I think we only need sine, cosine, or tangent based on the double angle formula. Well, now we're not given a triangle, so what we have to do is create our triangle. So I label the quadrants, and it says that theta has to be in quadrant 1. Well, when we're creating our right triangles, we have to create one that's going to be a central angle, and it's also going to be perpendicular to the x-axis. So we can say there's our theta. Now remember, tangent is opposite over adjacent, right? Opposite over adjacent. So therefore, cotangent is going to be adjacent over opposite. Well, you can see here, this isn't a fraction. So what can we do? Well, we can rewrite this as a fraction as 3 over 1, right? You can always write a number over 1. So therefore, I have 3 over 1. The problem is, we don't know what our hypotenuse is. So therefore, we have to use Pythagorean theorem to figure out our hypotenuse. So I do 3 squared plus 1 squared equals 3 squared plus 1 squared equals, let's just call this x, which is our hypotenuse. So therefore, it gets 9 plus 1 equals x, 10 equals x, or equals x squared, x squared, x squared, take square root, take square root. X equals plus or minus the square root of 10. I just switch those around. Remember, that's the hypotenuse, so that's always going to be positive. So that's going to be a positive 10. So now we just need to use the double angle. Now we just need to use our formulas. So first one, I'll do sine of 2 theta. Well, the sine of 2 theta is going to be 2 sine of theta cosine of theta. So sine, remember, is opposite over hypotenuse, right? Opposite over hypotenuse. So that's going to be 2 times 1 over the square root of 10. Times cosine, which is adjacent over hypotenuse. Oh, I guess I should tell you how to label those again, right? So remember that the hypotenuse is always directly across. The side length that's between theta and the right angle is our adjacent side. And the side opposite is our opposite side. OK. So then going back to it, cosine is going to be adjacent, which is 3 over the square root of 10. Now you just multiply these across. Remember, this can be rewritten as 2. So it's really 2 times 3, which is 6 over square root of 10 times square root of 10 is the square root of 100, which is just 10. Then I can reduce that. I can divide the top and bottom by 2. So that gives me 3/5. Done. Now let's go ahead and do cosine of 2 theta. So the most popular, often used formula for cosine would be cosine squared of theta minus sine squared of theta. Cosine squared of theta minus sine squared of theta. Just remember, these are still cosine of theta sine squared, but now they're going to be squared. OK, so cosine of theta, we said, was 3 over the square root of 10. And we're going to square that. Minus sine, which is 1 over the square root of 10. And we're going to square that. So therefore, 3 squared, and make sure when you're squaring a fraction, you square the numerator and the denominator. So therefore, this becomes 9 over 10 minus 1 squared would be 1 over 10. Which is equal to 8 over 10, which again, we can divide the top and the bottom, which is going to give us 4/5. All right, now let's go ahead and do the last one, the one that nobody wants to do, which is tangent of 2 theta. And I'm starting it all the way over here because through my experience, tangent is the one that's going to take the most amount of work on your paper when you're doing these problems. So tangent of 2 theta is going to be 2 tangent of theta divided by 1 minus tangent squared of theta. OK, so remember, cotangent was adjacent over opposite. So tangent is opposite over adjacent. So that's going to be 2 times 1/3 divided by 1 minus 1/3 squared. Well, 2 times 1/3 is going to be 2/3. Divided by 1/3 squared is going to be 1 minus 1/9. Then remember, we got to rewrite this so we can subtract 1 from 1/9. So therefore, I'll rewrite this as 2/3 divided by 9 over 9 minus 1/9, which is 2/3 divided by 8/9. Now, when you have a fraction divided by another fraction, to get rid of that, what we need to do is multiply by the reciprocal. So So that's 9 over 8 times 9 over 8. Any fraction multiplied by reciprocal is going to multiply to 1. Then we can simplify this. 3 divides into 9 3 times. 2 over 8 can be reduced to 1/4. So therefore, I am just left with 1 times 3 and 1 times 4. So it gives me my final answer of 3/4. Perfect. So there you go, ladies and gentlemen. That is how you evaluate for the double angle of sine, cosine, and tangent when given an equation as well as a constraint. Thanks. Thanks.